All right, welcome back to lesson 114. We're going to be learning how to graph square root functions today. So it's not going to be too hard because graphing is usually one of those things that it's not very hard. I'm going to teach you how to do it obviously by hand and with your calculator. All right, calculator, woohoo! After today, 6 more lessons to go. Appreciate the guys that are working alongside me. I get you. It's not fun. I would rather be in school. But yeah, what are you going to do? We work what we have. If life gives you lemons, then obviously you spray them in your eyes and you cry a lot about it, but then use them for something else. All right, so let's actually move on to lesson 114. Okay, so getting into the nitty-gritty. Example 1, they say graph this radical function. Square root function, y equals 2 square root of x plus 1. So what we did here was we are doing like the opposite of quadratic functions. The quadratic functions obviously are raised to the second power. This one are obviously square root. So let's actually look at a table, what it would look like, because that's what they're asking us. So the first one is obviously x, always for the tables, and then a y. So my first number is going to be 0. And then I'm going to have what happens when x is 0. When x is 0, square root of 0 is 0. 2 times 0 is 0 plus 1 is going to be 1. Okay? What about 1? Square root of 1 here is going to be 1. So 2 times 1 is going to be 2 plus 1 is going to be 3. Okay? What about then, we can't use 2 and 3. We could, but they're pretty hard numbers because we don't know what square root of 2 or 3 are. So what we're going to do is going to do square root of 4. Square root of 4 is 2. 2 times 2 is going to be 4 plus 1 is going to be 5. Look at that. We have 3 numbers. We could go again with something like 9. 9 is going to be 3. 2 times 3 is going to be 6 plus 1 is going to be 7. So we're going to graph our equation here, and it says that when x is 0, y is 1. Okay, so it starts at 1. And when y is 1, y is 3. 3. I'm trying to make it big so you guys can see it. And when x is 4, x is 4, y is 5. Somewhere around here. 4, 5, and then when x is 9, y is 7. And so it would look something like this. And it would just be like a curve that keeps on going like that. And it doesn't have anything else. This is, believe it or not, the opposite of a parabola. Why do I mean the opposite? Because a parabola could go up and down, like a happy face, or sad face, right? But the opposite of a parabola would be sideways. However, if I had a sideways parabola, it would never pass the vertical line test, and so we can't have that. And so a rational function, or a square root function, is going to be a function that is going to be just half of a parabola going sideways. And it could go this way, it could go this way, it could go obviously this way, or it could go this way. And it's always going to be like a curve, like a parabola would be. And so, yeah, that's what we're trying to show you. But again, this is not very hard. I'm going to show you how to do it in a calculator in a second. But yeah, this is how you graph with just a table. Obviously, first of all, the function, then the table, and then you do the graph. And it's pretty easy, okay? So let's actually move on to example number 2. Okay, So in example 2, we need to find the domain of two square root functions. So the first one is y equals square root of x minus 4, right? And the second one is y equals 3 square root of x over 2 plus 4 minus 7. Outside the parentheses, the minus 7. And so this is important to know. First of all, what is the domain? The domain are the x values, all the x values, okay? And so far, we haven't really talked too much about domain so far, because the domains for all linear equations and all quadratic functions are going to be all real numbers. What do I mean by that? I mean that for any other function that we've done, even for an absolute value function, the domain would be everything that there is, because we're going to use all the x values. This was a graph. Okay, x and y. This right here, it goes on forever and ever, and so it keeps on extending towards the infinity, negative infinity side of x, and the positive infinity of x. So this right here is going to be the way in which we know that the domain for any quadratic function is going to be all real numbers. What about a line? Well, a line is the same thing. It moved from negative infinity to positive infinity, and it hit every single point. However, for this one's, because there's something like this or something like this, look at that. It starts from here. It doesn't hit anything from there, or it starts from, well, I was going to do the line there, not there. It starts from there, that line, and so it moves on from there. Let me see if you can see. Yay, perfect. So that's what we're talking about domain, the x values. And so if you remember yesterday's lesson, the discriminants, it's going to be really easy because it has to do with the discriminant. The discriminant means whatever is underneath the radical or the square root sign. Now, it doesn't mean that these square root functions have discriminants, but it's the same concept, that the discriminant is underneath what is the square root or whatever the square root has. And so what we're going to do is we're going to combine two different methods of doing it. First of all, the discriminant, meaning what it's underneath the square root sign. And the second thing that we're going to do is we're going to solve for them like if they were 0, right? But not really solve for them. They're going to be inequalities. The inequality is going to be always greater than. So what we're going to say is this. X minus 4, which literally we just took from here. Put it right there. It's going to be greater or equal to 0. And then solve for this, which is going to be x is greater than or equal to 4. And that's my domain. My domain is from positive 4 all the way to positive infinity. That's my domain. Your book words it this way. The domain is the set of all real numbers greater than or equal to 4. So the set of all real numbers greater than or equal to 4. What about the second one? The second one's pretty easy too, because we have x over 2 plus 4 is greater than or equals to 0, right? Greater than or equal to 0. Now what we're going to do is solve for this, so it's going to be x over 2. Sorry, my board is moving a lot. Is going to be negative 4. And then when we multiply by 2, is going to be negative 8. X is greater than or equal to negative 8. How did I get that? Because I subtracted 4 on both sides, and then I multiplied 2 on both sides. So negative 4 times 2 is negative 8. So my answer here would be the domain of this particular square root function is going to be all real numbers that are greater than or equal to negative 8. And that's it. So I know that some of you thought it was too close for bonus, but hey, here I am giving you guys bonus again. So I'm going to give you bonus today, and I'm going to ask you For those of you who are watching on YouTube, down below you have to comment what is your favorite drink. All right, it could be water, it could be a particular brand of soda. I know that for most of you, you know that I love Snapple. Peach tea Snapple. It's probably one of my go-tos. And I love water. I love Snapple. I love Dr. Pepper. Those three are like my go-tos. And I do have peach Snapple during this quarantine. I can go without it. And obviously I do have water. I have tons and tons of water. Obviously from the sink, but also bottles. So yeah, good time to get a water break. So the first 5 people to comment down below what your favorite drink is, you're going to get 3 bonus points for the test, for next test. And if by any chance, and I keep doing this, I don't know if people are going to use it or not, because so far, not a lot of people have used it, but who knows? So if you are not within the 5 first people to comment down below what your favorite drink is, then you could go to where I linked this video in Google Classroom, and you can then write what your favorite pastime has been. Pastime meaning, have you been watching Netflix? Have you been playing video games? Have you been doing a bunch of stuff? Obviously, a lot of the students in class have been doing other things other than studying. So you guys must have been doing something. FaceTiming, doing TikToks, whatever it is that you're doing. Yeah, go ahead and tell me. Quick service announcement. If you love TikTok, watch out. TikTok is owned by a Chinese corporation. That information that you're sharing on TikTok and your personal information, it has been shared with the Chinese government. So not only the American government has your information now, also the Chinese government, because you have willingly given it to them. Since TikTok is not an American-based company, they don't really have to be regulated in what they do with the information that you put into TikTok or the videos or images that you put into TikTok. So there you go. Let's actually move on to example number 3. Okay, moving to example 3, it's about translating the square root functions. So instead of showing you in the board and doing everything like that, I'm going to do it in the calculator because I think it's going to be easier. So I already put a couple of square root functions into the calculator. So the first one is just the regular square root of x. So let's see what that looks like. I just have that one highlighted. I don't have the other ones highlighted, as you can see over here. They're not highlighted. So let's see how that graph looks. Ooh, look at that. So it does look like half a parabola right there. And then I just want you to compare it to the different ones that I put here. So the red one, what did I do to the red one? Inside the square root, I put plus 5. So let's see what happens in comparison. Will it move forward? Will it move backward? Will it move up? Will it move down? Let's see what happens. Did you see it moved backward? So when you put something inside the radical, inside the square root sign, like here, I put square root plus 5. If it's positive, it's going to be moved to the left, as you can see here, to the left. It's going to be moved to the left by 5. Okay? How do I know this? Because I put another one right here in the third one, the black one, my black graph, that it's going to be square root of x minus 5 inside the square root. And look at what happens when I press graph. You see, it goes forward 5. So if you have inside the square root a positive 5 or a positive 3 or a positive whatever, it's going to move backwards how many units you have here. So in here I have 5 because that's 5, right? But it's going to be moved back 5. In here, in the second one, I put x minus 5, right? So it moved forward. You see, it's forward. It moved forward 5 units. Now, let's not highlight this one. Let's highlight this one. In here, in the fourth one, I have square root of 5. Square root of x And then apart, outside the square root, I have minus 5. And look what happens. This is my original function. And what happened to the other one? Huh? Oh, I didn't highlight it. Good job. So let's try it again. I have that one, and then I highlighted it, and then it went down. It went down 5 because I put minus 5. So this one makes a little bit more sense because minus 5, it means that it goes down minus 5. And so plus 5, I think most of you who are watching still will know that it would be 5 up. Look at that. Boom, beautiful. Let's highlight all my equations. And that is a transformation. That's what happens. Transformation, meaning that if it moves left or right, it had to be because it was inside the square root. If it moved up or down, it's because it's outside the square root symbol. And that's pretty much it. So if you look at example 3, it says, describe the transformation applied to the parent function to form y equals square root of x minus 3. So what they ask you is the parent function. The parent function is the first one. That's always going to be the parent function of any type of function is going to be the easier function to do. So they ask you, okay, so what happened between that first function and if I put square root of x minus 3? Like what happens between that? Because we already saw, I can actually, and I know it's in the book, but I haven't seen yet. It's going to be 3 below. So it's going to be, it's going to start from negative 3. 0, negative 3. That's going to be my first point. 0, negative 3. Let's see. That's my parent function. And look at that. 0, negative 3. And it started from there. And that's the first one. The second example, it says, what happens, and let me move you right here. Boom. What happens? Describe the transformation applied to the parent function. So, by the way, the first one you have to say that it translated or shifted down 3 units. And the other one, it shifted It translated 2 units left. So shifting means up and down, and translated means left or right. That's important to note. This is, to me, actually, personally speaking, is not super important. I'm just more interested in you knowing what actually happened and telling me, oh, it moved to the left, it moved to the right, it went up, it went down. But, you know, the book's your book. So, in the second example, it says y equals 2x plus 2, or x plus 2, I mean, inside the parentheses, the radical, I mean. So I put it right there, and I graph, and I think it's going to move to the left 2 units. Oh, look at that. It moved to the left 2 units. Boom. And that's how you do that. So hopefully you understand that's pretty simple, especially if I showed you in the calculator. So inside the square root is going to move left or right according to what you put in there. And if it's outside the square root, it's going to move up or down. So now let's move on to example number 4. Okay, reflecting a square root function. So how do you reflect it? There's a way to reflect it, and I'm going to reflect this parent function that I showed you in my calculator by putting a negative sign in front of my function. So first, I put that, and my second one is negative square root of x. Look at what's going to happen. So my parent function is that one. And then the reflection is, oh, look at that. It reflected. Now it looks like a parabola sideways. But it's not. It's 2 different functions, okay? It's not one function. It's 2 different functions. So the blue one is my parent function. The reflection is the negative one, okay? So the negative outside the square root will make it go the other way, right? Upside down. And then in B, it says, okay, so what happens if we don't have the square root, the negative outside of the square root, but the negative inside the square root? Let's look at that. Negative x, square root, not squared. Come on, man. This thing is making me look bad. Not that I was looking at the first, obviously it was, but second, x, x, oh, negative x. Pfft, come on, Ming. Negative x plus 3. All right, so we have negative x plus 3, and I'm going to not highlight the second one, just the first one and the third one, and let's graph it. Let's see. So this is my parent function. We already knew that. Oh, look at that. It moved. Now, if I actually take off the negative 3, the negative 3 made it move up. But if I take out the negative 3, look at what happens. It's going to be like going the opposite direction. Not upside down, but the opposite direction. So that's what happened. So I hope that you understand. It's not very hard. I think it's not hard. The calculator will help you. It's not hard to look at it. So yeah, that's it for this lesson. Hope you liked it. There's only 6 more lessons to go. Hooray! I will see you guys on the next one.